So in the last video, we looked at how to implement a customized sampling design in Collectorth Online via Google Earth Engine, and we also gave an example of how to plan out your image interpretation project and bring it to life in CEO. And in this video, I'm going to show you how to download the data that we collected from CEO and how to make your end product out of that. So in this case, we're going to be using Google Earth Engine to make a machine learning generated land cover map. But of course, that's just one of the many projects that you could do using Collectorth Online. So first, we're going to navigate to our institution where we collected our data. Of course, we're going to log in if we haven't already. And then next to the project whose data we would like to download, we have a couple different options for downloading our data. We have the plot data, or the assessment unit data. We have the sample data, and we have the shapes data, which will be a shape file. These two will download as CSVs, and in this case we are after the sample data, so I'll click the S to download that, and you can see it went to my download folder. In this case, I only used one sample for each plot or each assessment unit, so these two are going to be similar. I'm just going to download the sample data. And now I'm going to open the Google Earth Engine code editor and bring this data into Google Earth Engine. So just going to open a new browser tab and type in code.earthenggine.google.com. And then I want to upload that data that I just downloaded as an asset in Google Earth Engine. So I'll click the Assets tab at the top left, click the red New button, and then click here where it says CSV file. And then I'll select that file that I just downloaded, click open, and then I want to give it an asset name too. It will just by default name it as the file name, but I can also give it a custom name and call it a final Ghana training data. And I'll just click upload. So while I'm waiting for that to upload, I can go ahead and navigate to our study area. Again, we'll just use this GAUL data set that we used previously and call it GAUL. And then I'll create a variable called Ghana where we filter that data set, which is just a filter collection to the country of Ghana. So there's a column called ADM0_name, and that contains a list of all of the countries, and we're just going to get the one row that's equivalent to Ghana. And then we'll add Ghana to the map and center our map on Ghana as well, with a zoom level of 5. And we'll run that to make sure that worked all right. So that went well. Now what we want to do is take our reference data or our training data, which is still uploading, and we are going to remap the land cover class names of that data to numeric codes. So I'll import this into the script. We can see it finished uploading because now it's highlighted blue, and we can click View Asset here and click Import to bring it in. We could also take a look at the features and see that it's the same file that we downloaded from Collectorth Online. So we'll click Import, and we'll call it ref data, short for reference data. And so what I'm going to do now is use this remap method in Google Earth Engine to take the land cover class names that are in this CSV file and remap each of them to a numeric code. So the land cover class names are going to be exactly as they appeared in Collectorth Online. I have them copied here. So I'm just going to paste them in a list, and we're going to make a variable called old LC, short for old land cover, and apply it, set this list to be equivalent to that variable. If you need to look up what your land cover names are because they need to be spelled correctly, they need to have the capitals, they need to appear here exactly as they do in Collectorth Online. So if we forgot what we called them, we could just go to our Collectorth Online project or to the CSV file that we downloaded and type them in exactly as they appear here. And then we are going to make a variable called new LC and just make it a list of integers between 1 and 9 with a step of 1. And I'll print that here to show you that that's exactly what that is. So now we're going to oops, print new LC. So now we're going to use that remap method to take each of these classes and assign them to a number. So tree cover will be assigned 1, shrubland will be assigned 2, so on and so forth. So let's do that right now by saying we're going to call this reference data remapped and say I want you to take that reference data feature collection and remap it from the old land cover class to the new land cover class. And we need to give a third argument here, which is going to be the name of the column where this land cover information is stored in our CSV file. So going back to our CSV file or just looking at our CSV that we downloaded from Collectorthonline, we'll see that that information is stored in this column that says what is the land cover type in 2022. And that will be the same as your question in Collectorthonline. So I'm just going to copy that straight from the Google Earth Engine asset and enter it in as a string, which just means text in between quotes. And let's print it to the console to see what that remapped reference data looks like. So you can see we've got a feature collection, and just going to the first feature in the collection and clicking on properties, we can see that the land cover type for the first point is grassland. So it's no longer in the CSV file as grassland, it's now in there as a 3. But we can just make a table to remember what number corresponds to what land cover class. So that's our first step, is to remap our reference data. Now our second step is going to be getting our input data. So this is going to be our imagery that we want to use for our machine learning classifier. So earlier in the project planning video, I told you that I wanted Sentinel-1 data, I wanted Sentinel-2 data, I wanted that Planet NICFI data, and I also wanted that Shuttle Radar Topography Mission, or SRTM data. So now it's just a matter of getting the data into the script. So we can just search, all these data sets are available within Google Earth Engine. We can just search them up top here. So I'm going to import Sentinel-1 first and call it S1. And now what I'm going to do is I'm going to filter this data to our region of interest. And I also forgot I wanted to specify a time period of interest. So I'll make a variable called start time and a variable called end time. And recall my year of interest or my time period of interest is the whole year of 2022. So now I'll use the filter date function to filter the entire Sentinel-1 data set to just the year of 2022, and I'll do that like so. And I also want to spatially filter that entire Sentinel-1 data to the country of Ghana, and we can do that using the filter bounds method. So this is still going to be an image collection, so we want to reduce it to a singular image, and we can use what's called a median reducer in order to do that. So we'll just use .median to take all of those images over Ghana in 2022 and reduce them to a single image. And finally, what I want to do is, I have to define these as variables, or declare them rather. And then I also want to see what bands are available in this data set. So I'll use the band names method in order to do that, and I want to print that to the console. And I called this start time. I wanted to call it start date. And same with end date. So we'll see here that our list of bands is going to be the VAV polarization, the VH polarization, but we also have a band for angle, which is the angle of the acquisition of the Sentinel-1 sensor, because it's acquired at an oblique angle, and that can change for each image. But we don't want to give this angle information to our machine learning classifier. We just want these different polarizations. So I'm going to use the select function to select just VV and VH. So I'll create a variable called S1 final and say I want you to select just the VV and VH bands separated as a list. And I will run it again just to make sure there's no errors. So as we can see, that worked pretty well. So now we're just going to do the same exact process on our other input data sets. So again, we can just go to the search bar and search up the Sentinel-2 data set and import it. We'll call it S2 and do the same filtering steps. And again, I want to print the band names to the console. So let's see what bands we have for Sentinel-2. So we've got 23 bands here. B1 through B4 are going to be our visible light, and the rest of B5 through B12 are going to be that near infrared, mid infrared, and shortwave infrared radiation. Bands 12 to 22 are going to be these different quality assurance and cloud and snow masking bands, and we don't want them included in our machine learning classifier. So we want to select, also we don't want to include the visible bands, bands 1 through 4, because we're going to use higher resolution Planet NICFI data in order to get that information. So feeding that information to our machine learning classifier from both Sentinel-2 and from Planet NICFI would be redundant. So we're just going to select bands 5 through 12. So make a variable called S2 final and set it equivalent to the median, but selecting bands 5 through 12. And we just want to separate these with commas. We'll run it again to make sure we didn't make any syntactical errors, which we did. We wanted that to say S2, not S12. And now we'll move on to Planet NICFI. Again, going to the search bar and looking up Planet NICFI. In this case, they're separated by continent, so I'll grab the one for Africa and import it here as Planet. You do have to sign up for the Planet NICFI program. And you can do that in the Google Earth Engine page for this data set. But it is free and open, and it doesn't take very long to sign up. And once you do, it will be available within GEE. So again, going to follow the same filtering steps. I'm just changing my variable names for Planet. And we will print our band names to see what we've got. So we have 4 bands here. We have a blue, a visible light band, green, red, and then we have near infrared light. In this case, we want to use all of those bands. But just so for consistency, so everything's named, the data set followed by final, we'll just select all of those bands really quickly. So we want to select B, R, G, and N. And run it. And finally, for the SRTM digital elevation data, this is not going to be an image collection. This is going to be a single image for the whole planet. So I'll import that in here. And instead of doing all of that filtering, we are just going to clip it to the region of interest. And I'll call it SRTM final equals SRTM, which is the data as it was imported. And we'll clip it to Ghana. I also forgot that I wanted to clip each of these final composites to Ghana as well. So I'll just do that really quickly. And run the script again. Oh, and we can also see the bands of SRTM, but we are going to see that there's only one band for elevation, so we don't have to select anything. We have to print it to the console to see that. So now we have all of our input data. It's capturing a whole lot of information from the entire year of Ghana, or the entire year of 2022 rather, over the entire country of Ghana, and it's being composited or reduced rather into a single image for each of these data sets. But now we want to take each of those separate data sets and combine them into a singular image. And we're going to have all of these different bands represented within this image. So we can do that using the add bands method in Google Earth Engine. So we will say input data, and we will take S1 final and add the bands of planet final, and we'll add bands of Sentinel-2 final and add the bands of SRTM final. And let's print that to the console to see what that looks like. So our next step, or really quickly, let's take a look at that. So the bands here, we can see we've got our Sentinel-1 polarizations, we've got our planet data, we've got that mid and shortwave infrared from Sentinel-2, and last but not least, we've got that SRTM elevation data. So now we're going to use a method called sample regions, and that's going to allow us to go to every point, every feature within this feature collection, and get the spectral response of all of these bands at each of these 755 points. And then we're going to use that information we're going to give that information to the machine learning classifier and separate our points into different classes. And it's going to pay attention to what we've classified each class as in Collectorth Online, and remember that information is stored here within that feature collection. So first, we have to use this sample regions method. So we are going to say input data sampled, or we can say ref data sampled rather. And we will say, I want you to take the input data and sample regions. So we can see we need to feed a couple of arguments to this method. So first we need a collection. So that is of course going to be our reference data, which we called reference data remapped. And that's just this feature collection. We also want to give a scale. So that scale is going to be 10 in our case. And we finally want to specify this geometries parameter. This is set to false, but we want to preserve the geometries of our reference data. And we will run that. So now we are going to get our classifier and train it. So I will use the random forest classifier. So we'll call it, create a variable called train classifier. And we will use that smile random forest classifier. This is only going to have one mandatory argument, and that's going to be the number of trees, which is the number of decision trees to create in the machine learning classifier. So we'll make it 100, and then we want to train the model. And let me pull that up really quick. So to do that, we need features, we need a class property, and we need input properties. So the features are going to be the reference data sample data collection, or feature collection rather, that we just made. And then the input properties are going to be, or rather the class property is going to be the same as the what we put in here in our ref data remapped variable, it's going to be the name of the column where our land cover class information is stored. So I'll just copy that from there. And finally, we want input properties. And these are going to be the different bands in our input data. So to get that, I can just make a variable called input bands and use our favorite method, the band names method. So I'll just type that in here. So now we have our train classifier. All that's left to do is to use the classify method to take our input data image and classify it based on this trained classifier. So I'll just say image classified is our input data dot classify based on that trained classifier. And finally, I want to specify some visualization parameters. So make a variable called VP. And the minimum, if you recall, will be 1 up here. That's our minimum value, and our maximum value is going to be 9. I will add a color palette, so when we visualize this data, it doesn't appear as grayscale, but it will take a minute for this to add to the map. So I am going to run it first. But as we can see, I got an error because I spelled my variable wrong. And now it's running. So it will display these different land cover classes as different shades of gray. And while it's running, I can go ahead and, oh, I forgot to add it to the layer, or add it to the map. So we will use map.addLayer and add our classified image, our visualization parameters, and we'll just call it random forest. And we'll click run. And while that's running, it'll show up as grayscale, but let's add the palette while we're waiting for that. So this is just a list of colors that are represented by these 6-character strings known as hex strings that I'm typing in now. And this is just the same color palette as the world cover map that I use to stratify my sample. And you can see this gray bar on your Layers tab in Google Earth Engine will tell you how much progress it's making in adding it to the map. So we can see it just started to add some of that information to the map, but I'm going to rerun it with this new color palette, and we'll see what happens. So it did take a while for that to add to the map because it's at such a high resolution and for a large area. But as you can see, we've got our land cover map with our different colors for each land cover class. So this looks great, but we want a final product that has a legend and is just a singular image of this land cover map without any of this background information. So to do that, I'm going to use a software called QGIS that's free and open source to turn this map into a final product. So to get this map into QGIS, I'm going to export the image to Google Drive. So I'll use this export image method here. I'm going to give it this image that's displaying on my map, which we called IMG classified. I want to provide a scale, which was 10 meters. And I also want to provide a CRS, which is just the projection. This is the projection of this map, and I'll show you how to find out the projection of an image shortly. I also want to specify a file format, which in this case is going to be the GeoTIFF file format. And there is another argument I want to give called max pixels. And so you have to specify this argument if your image has a very high number of pixels. Otherwise, it will not run. So this is the maximum that we can set this argument to, is 10 to the 13th. And I found out all of these parameters from just looking in the documentation here. And then we also want to export our shapefile of Ghana. And so I am going to do that right here. And I'll specify the file format as a GeoJSON file because those work very well in QGIS, which is the software that I'm going to use to make my map. So we'll go ahead and run those. And our taskbar will light up, and we can run both of these. And I'm just going to give them a name so I know which one is which. And those are running. The table will run fairly quickly, but this image can take a couple of hours depending on the scale and the size of your map. So I will use a pre-existing one when we go to QGIS. But first I want to show you how to find out the projection of an image to put here when you export your image to the drive. So I can just make a variable called PRJ and set it equal to the projection of that image with empty parentheses. And then when I print that to the console, it will show me what my projection is. Again, it will take a while to run, so we'll come back to it later. But that's how you're going to find out what your projection code is to give to the CRS parameter when you're exporting your image to Drive. So as we can see, our table task has finished exporting to our drive, but our image is going to take much longer. So I exported this image beforehand, so I'm going to use this one in the demo for now. You can see mine took 2 hours to run. I'll just open my Google Drive and download those files. So here is my shapefile of Ghana. We'll download that. And then depending on the size of your image, it may export to Google Drive as multiple tiles like mine did. So I will download those. Then I'm going to open QGIS and open a new project in QGIS. We can also add our OpenStreetMap to this project by going to OSM and clicking OSM Standard, and you can see we've added just a nice base map for us. So then I'll open my file folder and bring in the GeoJSON file as well as the image files. So my image files are still downloading, but I downloaded them earlier. Oh, they just finished, so we can unzip them there. And then we'll bring each of these images, which are saved as .tiff files, into this project. And they'll take a minute to add there. But we'll see that Google Earth Engine divided our study area up into each of these tiles. And we also have our shapefile of Ghana here as well. So the first thing we're going to want to do is to take our various tiles of the image and merge them into a single one. And we can do that fairly easily with, you can't see it in my recording, but up at the top of QGIS there will be a icon that says raster. We'll go ahead and mouse over that and scroll down to extraction, and then, we want to go to miscellaneous and then go to merge here. So then this will open this other dialog window. We can click these 3 dots over here to specify our input layers, and we want all of our different tiles. So I'll check all those, and then we just click run. This will also take a decent amount of time to run, but when it's finished, you'll have something that looks like this, which will just be a singular image of all of those rasters combined into one. So I ran this a little bit earlier, and I just had it saved to this project so I could show you what to do next. So now we have our output file, but we can see that we still have a bit of an issue because one, our land cover classes are not their different colors as they appeared in our Google Earth Engine script. And also we're not showing just the map clipped to the extent of Ghana. We have values of 0 here outside the country of Ghana, and so they're showing up as black. But that's not what we want, and that's why we brought in this shapefile of Ghana so we can clip the output of this image to the country of Ghana. So we can do that by going again to raster. You can't see it, but it'll be up at the top here. And then we will go to extraction and then go to clip raster by extent. So I'll take that layer called merge by clicking here and going to merged. And then for clipping extent, that will just be our Ghana shapefile, which was called my export table task. And then what we want to do is assign a specified no data value. So this can be arbitrary, but I like to use -999 just to make sure that no other data file would also be that value, and then click run. This will go much faster, and then what we'll do is assign that no data value of 999 to be transparent so we can't see it in our final map. And then once we do that and we specify our color palette, we will be ready to go. So as we can see, it finished. It won't look any different right now, but once we go into the properties and change our symbology, we'll be able to see that all of these values outside of the boundaries of Ghana will be set to that no data value, and so we can set them to be transparent. So I'm going to go to paletted unique values instead of single band gray. Because recall, each one of our land cover classes has a discrete value of an integer, and they all have different integer values. So first, we'll just add a couple colors here, and then we will specify first our no data value, and we'll just say no data, and we'll click this color here and bring the opacity down to 0% so it's transparent. And I'll quickly just show you what that looks like. We can see everything outside of the boundary of Ghana has been removed, or is transparent rather. And then what we want to do is go back to properties and change all of these colors to the values that we had in our Google Earth Engine script. So instead of following the color scheme exactly, I'm just going to continue with these arbitrary colors. But if you wanted to use those hex values, or those hex strings rather, for your colors, just like we did in Google Earth Engine, we could write the hex codes there. So I'll just assign our labels now. And again, I know what the value for each of these is based on our Google Earth Engine script. I know for bare and sparse ground, we wanted a nice gray color. And I'll just refer back to my Google Earth Engine script here to remind me which value refers to each land cover class. So we had permanent water bodies. Oh, and I did forget cropland here. So 4 is cropland, 5 is built up, and 6 is bare and sparse vegetation. Built up, we wanted to be red. Oops. Bare and sparse vegetation, we wanted as gray. Permanent water, we'll get a nice blue. And then for mangroves, we had a light green, and herbaceous wetland we had as a nice teal. So we've got some nice, I'll change this to orange to make it stand out from tree cover a little bit more. All right, so we've got a nice color palette. We can click OK, and we can see our color palette has been updated. Not the best looking map, but for the purposes of this video, it will do. So now to export this as an image, what we're going to do is go to Project at the top bar here and go to New Print Layout. And we'll just call it Map Output. So I will just click this button here to add our map to the print layout and just drag and drop. And then we'll also add a legend by clicking here. And you can see for the legend, it will add everything that you have as a layer, but we can remove the items that we don't want to show there. And we want to remove everything except for this final map, which was called clipped extent. So I'll just control select everything that I don't want to appear there. And remove it from the legend. We can see it automatically added in our labels for each land cover class. And so then I would want to spend some more time to make this image look a little nicer, to zoom in a little bit on our land cover map here, remove this information like band 1 gray and no data from the legend, as well as make a nice title from our legend, maybe add a scale bar as well. But for the purposes of this video, I'm going to show you how to just export your image, or your map rather, as an image file from here. So I'll go to Layout in the top left and then click Export as Image. Will show us this message. We can close that, and then we can just give our output file a name. I'll call it Output Ghana, and click Save. We can pick the DPI of the picture as well as the width and the height, and then we'll click Save. And as we can see, our layout has successfully exported, and we can open it as a PNG file and upload this to this course as our final land cover product. Of course, yours will hopefully look a little bit prettier than this, but that is how you implement a image interpretation project in Collectorthonline from scratch and go from having no training data to having a complete land cover map for an entire country. So thank you for listening. Collectorthonline has received financial support from NASA, the U.S. Agency for International Development, or USAID, the Food and Agriculture Organization of the United Nations, or FAO, the U.S. Forest Service, Silvacarbon, Google, and the Spatial Informatics Group. It was co-developed as an online tool housed within the Open Forest Initiative of FAO. Collectorthonline was initially developed by Surveyor and is now supported by a broad base of partners. And it was inspired by Collect Earth, a desktop software developed by FAO. The development team of CEO includes Arthur Lewes, Jordan Combs, Matt Spencer, Richard Shepard, Oliver Baldwin Edwards, Sif Beery, Roberto Fontanarosa, Francisco Delgado, Githika Tondapu, Billy Ashmall, Nishanta Kanal, John Dilger, Karen Dyson, Karis Tennyson, Cal Markert, Africa Flores, Emil Sherrington, and Eric Anderson. The Collectorthonline curriculum was organized by Surveyor's Science Coordination Office, with individual models created by NASA, USAID, NASA's Earth Observatory, the Spatial Informatics Group, and Surveyor's Science Coordination Office. These individual modules were created by Crystal Wespestad of Spatial Informatics Group, Holly Rybeek and Robert Simon of NASA Earth Observatory, Billy Ashmall, and myself, Mickey Maganini, of Surveyor's Science Coordination Office. Review of the material was conducted by Surveyor's Science Coordination Office, including Kelsey Herndon, Emil Sherrington, Billy Ashmall, Deanna West, Katie Walker, Lauren Carey, Jacob Abramowitz, Jake Ramthen, Natalia Bermudez, Stephanie Melik, Emily Adams, Stephanie Jimenez, Vanessa Martin, Alex Goberna, Francisca Delgado, Biplab Bhandari, and Amanda Markert. Crucial insight regarding the development of the curriculum materials was provided by Claudia Paris and Andrea Puzzi-Nicolau. Review of the material was also conducted by Bart Kroll and Laura Cray of ITC, the Faculty of Geo-information Science and Earth Observation at the University of Twente. The course and unit banner images used in the course were created by Gianluca Ambrosi of ITC.